Hey, welcome back, and moving on with our discussion of the chemical basis of life. This is the first part. This is a lot of the inorganic chemistry, and we've been talking about water. And as part of our discussion on water, we're going to look at pH. And you're probably familiar with pH. pH is a measure of the acidity or the alkalinity of a solution. And this discussion actually comes from the fact that water will dissociate into protons, a H plus ion, a hydrogen ion, and a hydroxide ion at a very low frequency. So this is actually a natural extension of my discussion on water. So what is pH? pH is simply a measure of the concentration of protons in solution. So we talked about concentration. Concentration measured in molarity, remember, is the number of moles of a substance. So that could be a number of moles of protons in a given volume in liters. So we could talk about a 1 molar solution of protons, and then we would have 1 mole in 1 liter. So we're talking about the concentration of something, and so that's going to be our solute. And here it's just protons. It's just a hydrogen atom that has lost its electron, which has left the positively charged nucleus, which is just a proton. If you look at the structure of a hydrogen atom and you take the electron away, you're left with just the proton. So that's just a positive charge in the nucleus. So that's what a proton is. And so the pH is just a measure of the concentration, so the amount per unit volume of protons in a solution. And in a little bit, we'll go on to talk about buffers, and pH and buffers go hand in hand because changes in pH are not good for biological systems, and so buffers help you help your body control the effect of changes in pH, and so that's going to be the biologically relevant piece. But we've got to get through pH so that we can have a discussion on buffers. So here is the pH scale. pH scale goes from 0 to 14 as far as we're concerned. Now, the important thing about the pH scale is that it's a logarithmic scale. And if you're not too sure what a logarithmic scale is, then get on Google and look up something like what is a logarithmic scale. So a logarithmic scale is when you go from one point on the scale to the next, and that's a 10-fold or a 10x jump. So for example here, if we go from pH 7, which is in terms of pH, it's in the middle of the scale, so pH 7 there, if we go from pH 7 to pH 8, that's a 10-fold change in the proton concentration. And then if we go from pH 8 to pH 9, that's another 10-fold increase, and from 9 to 10, that's another 10-fold change in the proton concentration. So if we go from pH 7 through 8 to 9, that's 10-fold times 10-fold, that's a 100-fold change in the pH, in the proton concentration. So that's a lot. I mean, imagine if your salary or your pay or your stipend or whatever you get went up by 10-fold or 100-fold or 1,000-fold. So imagine that was happening, then that's a lot. So that's the first thing about the pH scale. So the second thing about the pH scale is it's kind of an inverse scale. So what I mean by that is that if you're at the lower end of the scale, down here, 0, 1, 2, 3, 4, towards 7, down at the lower end of the scale, as the numbers get lower and lower and lower, the proton concentration goes up. And students always get this wrong. They always think that because the pH scale is going down, the proton concentration is going down, but that's completely wrong. This is an inverse scale, so the lower the number on the pH scale, the higher the proton concentration. So then the flip of that is true. If we go from 7, 8, 9, 10 upwards, then we're looking at a decrease in the proton concentration. So for example, if we went from pH 5 to pH 4, that's a 10-fold increase in proton concentration. If we went from 4 to 2, that's a 100-fold increase in proton concentration. If we went from 11 to 12, that's a 10-fold decrease in proton concentration. So two things to remember about the pH scale. It's a logarithmic scale. That means each change of number, 1 up 1 or down 1, is a 10-fold change. And the second thing is that as you go down the scale towards 0, proton concentration goes up, and as you go up the scale towards 14, the proton concentration goes down. So let's just kind of put this in context of some things you know. pH of pure water is 7. So that's with no impurities, nothing added to it. Pure water will have a pH of 7, and that's because 1 in every 10 million or 10 to the 7 water molecules dissociates into a proton and a hydroxide ion, and that means the proton concentration in a liter would be 10 to the minus 7 molar. We can talk about that offline if you're interested in that. So at pH 7, so that if we measured the concentration of protons at pH 7, is what we would see is that the proton concentration is 10 to the minus 7 molar. So some of you are going to start to see a relationship here pretty quickly. And if we jumped up to pH 10, that's going up 3 steps. So remember, that would be going down 3 orders of magnitude in terms of the pH concentration, proton concentration. Then the proton concentration at pH 10 is 10 to the minus 10 molar. Let's go the other direction. pH 3, the proton concentration is 10 to the minus 3 molar. So some of you are probably seeing a relationship at this point, and so here is the relationship that you should probably be seeing at this point. That for any given pH, the proton concentration is simply 10 to the minus of the pH. So if I said pH is 6, then you would say 10 to the minus 6 molar is the concentration of protons. If I said pH 2, that would be 10 to the minus 2. So all you do is you substitute the numerical value for the pH into where I've got pH in this little equation here. So if this is 2, then you put 2 here, and that becomes 10 to the minus 2 molar, 0.01 molar. So that's the relationship, and the way that we get this relationship is from this equation here. So mathematically, the pH is the negative log of the proton concentration. So let's just kind of talk this through really quickly. So if I said the proton concentration was, I don't know, 10 to the minus 10 molar, so that's a proton concentration of 10 to the minus 10 molar. If you put 10 to the minus 10 into your calculator and then do negative log, you're going to come out with 10. Okay, so think about it like this. If you take 10 to the minus 10 and then you take the log of 10 to the minus 10, that is 10. That's minus 10, sorry. And minus 10 is 10, so the pH would be 10. So the proton concentration is 10 to the minus 10, you take the negative log of that, the pH will be 10. So learn how to use your calculator. You're going to have to do some of these problems on your quiz and probably in some of your homeworks. So last thing we're going to do in this little short section, a few questions, same thing as usual. Put the question up, pause your video, read the question, and then when you start your video again, I'll release the answer. So as soon as you see the question, pause your video immediately. That way you don't see the question answer come up before you've had a chance to read the question. So here we go. Here's the first one. See how you get on with this. Okay, here's your next question. Your third question. And your fourth and last question in this section. Okay, so that wraps up our very brief discussion of pH. Next time when we come back, we'll talk about buffers. And for your learning outcomes, make sure you can calculate pH because that's going to become important when you do your learning outcomes.